Hey everyone, welcome to Introduction to Matrices. In this video, we'll cover what are matrices, what are different operations that we can perform on matrices, and then we'll focus on matrix multiplications. Okay then, let's get started. We have previously explored vectors by expressing them in matrices. A matrix is an array of numbers that can be represented in rows and columns. It is generally represented by a capital letter. Here I'm writing a matrix A that is a 2 by 2 matrix and a matrix B that is also 2 by 2 matrix. Now let's perform our first operation on these two matrices, that is addition. To add these two matrices, we will add the individual rows and columns A of ij with B of ij to get the resultant matrix. Now this is the resultant matrix that we get after adding these two matrices A and B. Now let's see what is the negative of a matrix. So a negative of B, we will change the sign of each of the positive number to negative and negative to positive to give the resultant negative matrix. This is a negative B matrix, and similarly we can write a negative A matrix. Now this is B transpose. Transpose is an operation in which the rows become the column and the column become the rows. So B transpose, all the row elements will become a column elements and the column element becomes the row elements. Now let's talk about matrix multiplication. A matrix multiplication is very similar to a vector dot product. So I will rewrite my two matrices A and B, and then we'll perform matrix multiplication between these two matrices. Now there is one more type of multiplication, that is scalar multiplication, that is similar to vector scalar product. In a scalar product, the matrix is scaled to the scalar value. To find 3 times matrix A, each of the individual component of the matrix will be scaled by 3. So here we'll multiply each of the component by 3 and get the resultant matrix. Dot product multiplication requires two matrices in which the number of the rows in the first matrix is same as the number of columns in the second matrix. Here are two rows being multiplied by two columns in this example. So the dot product of this matrix will have four elements. To calculate the elements in the first row and the first column of the result, we multiply each element of the first row in the matrix 1 by the corresponding element in the first column of the matrix 2 and add the results. And we'll quickly do the same for all the elements of the matrix and compute our values. And this is the resultant matrix that we have got after the matrix multiplication. Now let's quickly talk about the identity matrix. Identity matrix is similar to multiplying any number by 1. So if we multiply any matrix by identity matrix, we get the output as the same matrix. Okay guys, so now let's jump into our Jupyter notebook and see how these concepts are implemented using Python. We will import NumPy and we'll create two 3 by 3 matrices M and N, and we'll perform these operations on these matrices. If you're watching this video on YouTube, make sure you check out the description. In the description, we have the link for the repository where you can try the hands-on in all those exercises that we're discussing currently. Now we have created our two matrices. Let's print them out. Rank of a matrix is the linearly independent rows or columns that are present in the matrix. Here we have a 3 by 3 matrix, so the rank of this matrix will be 3. We'll use the NumPy functions that help us to know what is the rank of the matrix. The NumPy linear algebra module and the function matrix rank help us to identify the rank of a matrix. Similarly, we can use np.transpose to transpose a matrix. To find the matrix multiplication of two matrices M and N, we'll use numpy.matmul function. We will run this cell and check the output from each of the operations. So we have these two matrices. The rank of the matrix is 3. In the transpose of the matrix, we can see our row items are now column items and the column items are the row items. We also have our matrix dot product in the form of 3 by 3 matrix. So guys, this was a brief introduction to matrices. We'll meet again in the next video. Till then, goodbye.